Hello, my name is Rafael de la Cruz, and today I'm going to be showing you guys how to graph a hyperbola. So first of all, how do we know that this equation is a hyperbola? Well, first we need to notice that it is in general form, which means that this term here is term A, and this term here is term C. Now, whenever we have this, put this down, we know that if AC is less than 0, so if you multiply A, which is -1, the coefficient of the x squared term, and C, the coefficient of the y squared term, and if it's less than 0, meaning if it's negative, then the equation represents a hyperbola. Now, to get this equation into standard form for part B, first we can move the constant over to the right side by adding 48 to both sides. Next, we can group or order these by their terms. So I'm going to have x squared here and right next to the x, and the y squared next to the y. So first thing we need to notice that if you want to make this into standard form, we have to complete the square in order to get a perfect square trinomial. So what this means is, first we need to factor out a -1 from this x squared and this linear x to get the x to have a coefficient of 1. And the same thing for the y squared, we want it to have a coefficient of 1, so we're going to factor out a 4 from both this term and this term. So that's what we can see here and here. Our goal here is basically to get these terms to make a binomial squared. So I will have a little picture of what that looks like right there. There's a pattern that you can follow to complete the square. You can half the linear term, so in this case it's 8, half that and you get 4, and then square it to get 16. Now if we add 16 here, that means we also have to add 16 to the other side. But it's important to note that this is actually subtracting 16 because of the negative sign. So this is subtracting 16, so we're going to subtract 16 from the right side. And same thing with this. We're going to half the linear coefficient, which is -2, and that results in 1. And square that, we get +1. 1 times 4 is equal to 4. So we're going to add 4 to both sides, or basically you're adding 4 to both sides. Next, after that, you see that you have -x plus 4 squared plus 4 times y minus 1 squared equals 36. This 36 just comes from adding all of these up. And then this, if we were to expand it out and multiply it, would equal this trinomial right here. And same thing for this. So this is the perfect square trinomial that we're looking for. In standard form for a hyperbola, the right side, or the side without any variables, is equal to 1. So we're going to divide everything by 36.
I also forgot to mention that I made it so that it is the positive term minus the negative term. So the y term minus the x term.
And then once we do that, 4 over 36 simplifies or reduces to 1 over 9. And then 36 just stays here because there's nothing to reduce. And then you get this equation right here, which is our hyperbola in standard form. Just like this. This is how the hyperbola is supposed to look in standard form. The center is always h, k. So in this case, our h right here is equal to -4. And our y is equal to just 1. Alright, so next, part D asks us to find whether if it's a vertical hyperbola or a horizontal hyperbola. So how can we tell that this is a vertical hyperbola? We can tell it's a vertical hyperbola because the leading term, basically the term that is positive, will tell you if it's either horizontal or vertical. So in this case, the term that is positive is the y, and the term that's negative is the x. This means that the hyperbola will be vertical, meaning that it will expand upwards and expand downwards. So the transverse axis has to be vertical, as it is a vertical hyperbola, and it goes to the center, -4, 1. If our transverse axis is going to be x equals -4. So right here I have it plotted out on the Cartesian plane, -4, 1 for our center, and I have our transverse axis at -4. And then, so our next step is to find the fundamental rectangle. And our fundamental rectangle can be found by identifying A and B. So our A is going to be the square root of 36, because 36 is where our A position is, A squared, so we must square root that. So our A equals 6, and B square root 9 equals the square root of 9, which is 3. So we're going to go up 3, and then down 3, to the right 6, and to the left 6, and then just connect all of that to get this beautiful rectangle. For part F, you're supposed to find the vertices of the hyperbola. So we can find the vertices by looking at these points right here. Because we know it's a vertical hyperbola, it will go down like, there will be a graph that goes like that. And it goes through the transverse axes and it hits the fundamental rectangle. So in this case, it's going to be -4, -2, that's this point, and -4, 1, or 4. Part G asks us to find the focal length. So our focal length is equal to plus or minus the square root of b squared plus a squared. So if you plug in b, you get 36 plus 9. The square root 36 plus 9 equals 45. And the square root of 45 can be simplified to 3 square root of 5. Don't forget the plus minus though. We have to add that to our y value because it goes up and down. So keeping the same x value, our first focal length is -4, 1 plus 3 square root of 5. And our second focal length is -4, 1 minus 3 square root of 5. Next, we are asked to find the equation of the asymptotes. So first, we know that our asymptotes are straight lines, so we can use this equation y equals mx plus b, and we can plug in our center, -4, 1, because both asymptotes go through the center. And for our slope will equal plus or minus b over a, and I'll explain to you why that is. If our asymptote goes through the center to the vertices, then we know that a slope is rise over run. So this is b over a. And then also there's also one through here. So we can go -b over a. So we plug in our b's and our a's and we get plus or minus a half. So we can plug in our points, our center points, to the equations and then use half and -half. So half times -4 equals -2. Add 2 to both sides, you get 3 equals b. Same thing for this side. -4 times a half equals 2. Subtract 2 from both sides, you get -1 equals b for that equation. So then we get this asymptote, which is y equals half x plus 3. And this asymptote is y equals -half x minus 1. Next, we are asked to graph everything. So first, when I started graphing, I started with the center. So our center is -4, 1. I graphed my vertices, -4, 4, and -4, -2. So that's there and there. And then I proceeded with my rectangle. And then I drew the asymptotes according to these equations. And they go through the corners of the rectangle. I also forgot to mention that I drew my transverse axis right here. That's the equation, x equals -4. And after that, I drew my hyperbola, going through the vertexes or the vertices, and slowly getting closer to the asymptotes. It's also important to note that these hyperbolas are not just two parabolas. Hyperbolas have asymptotes that they have to follow, while parabolas don't. For our intercepts, you know that there are no x-intercepts because the line starts here and goes down, starts there and goes up, so it does not ever pass the x-axis. And for our y-intercept, we can set our x equal to 0. Do some math. Here is our equation in standard form. I'll multiply by 36 to get rid of the fractions, and then sub 0 for x to get 4 squared, which is equal to 16. This is a negative 16, so I add 16 to both sides to give me 52. Then I proceeded to divide by 4 to get rid of the 4 on that side to give me 13. Then I have the square, so I square rooted both sides, gave me plus or minus square root of 13. And then I added the 1 to both sides. And then here are my y-intercepts, and they are also graphed. Now for our domain and range, our graph will continue to go left and continue to go right forever. So that means our domain is negative infinity to infinity. Now while the same is true for our range, it goes down forever and up forever, there's this gap in between. So that can be represented as negative infinity to negative 2, bracket in union with bracket 4 to infinity. And those are the points right there. And they go up and they go down. And there you have it. That is how you graph a hyperbola. Thank you very much.